All right, peeps, this is part 2 because I got cut off. Okay, so we were talking about inverse square law. We had already identified all the parameters for what those stood for. And I was saying that a radiologist stood 10 inches from the fluoro tube and got a badge reading of 412 millisieverts. Millisievert is a occupational dose. So as a radiologist, his badge reading would read 412 millisieverts, and I am totally making these numbers up. They're not coming from anywhere. I'm just throwing them out there just so you can see that we can work through. It doesn't matter what numbers they give us. If he moved to 16 inches away, what would his new badge reading be? My videographer is trying to check and make sure that I have good, I think it's good. Badge reading B. Do you agree? You can look, they can't see you. She said it was cutting off my head before, and she didn't like that. So, the board, not me. Who cares about me? Okay, so radiologist stood 10 inches from the fluoro tower, got a badge reading of 412 millisieverts. If he moved to 16 inches away, what would the new badge reading be? So you're trying to see if he's going from 10 inches to 16 inches, he's getting further from the source, correct? So from what we know, if he's moving farther away, he should get less dose. So what would be the first thing I would tell you if you were approaching this and had no clue how to work this out? What I would personally do is underline and say what these stand for. So radiologist did 10 inches. That's the first thing that sticks out. 10 inches is a distance, correct? And it happens to be the first distance that we're talking about. So I would label this as D1. 10 inches from the fluoro tower, got a badge reading of 412 millisieverts. 412 millisieverts isn't a distance, but it's an intensity. It happens to be the first one, so I would label it I1, but what you always have to ask yourself is, does it go with 10 inches? Do the I1 and D1 go together? So when he was at 10 inches, he got 412 millisieverts, so those do go together. If he moved to 16 inches away, that would be our D2. And then it says, what would the new badge reading be? So this new badge reading is our X, what we're solving for, and it happens to be our I2. Okay, so if you do that, then all you have to do is go back in and plug the numbers. So the formula says it's I1, which is 412. So 412 over I2, which is our X, is equivalent to D2 squared. D2 is 16 inches squared over D1 squared, which was 10. Cannot forget to square your distances or your numbers will not come out right. All right, now everybody has their own way of doing math. I'm just going to tell you what works for me. And if it works for you, great. And if it doesn't, I don't care how you do it, as long as you get the right number. So personally, for me, I'm going to tell you that the first thing I like to do is get rid of my my exponents. So 16 squared literally means 16 times 16, correct? And 16 times 16 is 256. And 10 times 10, I think we all know the answer, but just to prove it out, 100. So 16 squared is gone, I have 256. 10 squared is gone, I have 100. Then what? Then it's simple algebra. We cross multiply, okay? So I like my X on the left. I don't know if it's because I'm left-handed. I just always like it over there. So I'm going to take 256 times X, and I get 256 X equals 412 times 100, which is 41,200. Okay, so 256x equals 41,200. Now I have to solve for x. How do you do that? Well, if this is 256 times x, then to get rid of that, you would divide by 256. And if you do it to one side, you have to do it to the other. So 256 divided by 256 leaves us with x, and 41,200 divided by 256 leaves us 160.9375. But I'm going to tell you that I typically cut it off 2 decimal places, and I don't round. So 160.937, I'm going to leave it as 93. 160.93. Don't round. Don't, just because the next number is a 7, don't make that 4. Just cut it. 160.93. Now, what is that? Because it needs a qualifier. And if you don't give it a qualifier, it's wrong. So our I2, we're going to put the same units as we did in the first intensity. Just like if we were answering in inches, the second one ideally would be in inches. If this was 412 millisieverts, then this is 160.93 millisieverts. And this is our answer. Now, does it make sense? If he backs up 6 inches, he goes from 412 down to 160. So if he's moving away, is the number going down? Yes. So without doing the math, because you can always plug it back in, that seems as if it's appropriate. If you got a number higher than 412, that wouldn't make sense, because you shouldn't have to go farther away and your reading go up. The farther away you go, your reading should go down. If you're getting closer, that's when your reading goes up, right? All right, so with this particular formula, we were solving for I2, and that's what we got. Now I'm going to show you one other way, because if your variable is on this side, this is what you're going to do every single time. If the variable's on this side, it's a little bit different. So I'm going to erase this and give you another problem, and we'll work through it together. Now, hopefully this is making sense to you, because with math, the nice thing about math is that you can always go back and make it work out. You can plug your numbers back in and make sure they work. So you should always know if your answer is right or wrong without having to wait for it to be graded. Okay, the other nice thing about math is that sometimes it just makes, if it makes sense, if you're getting closer, then it does this. If you're getting further, then it does that. All right, so there's our formula. I left that up for you. I think you guys can see that. There we go. All right, let's give a new one. Let's say that a technologist, I'm going to abbreviate. I know you shouldn't, but a tech stood 6 inches away from the C-arm in the OR and got a reading see, 6 inches, that's pretty close. Got a reading of 811 millisieverts. Let's say she wants her badge. She wants her reading to be 500 millisieverts. So to what distance does she need to move? Okay, so texted 6 inches away from the C-arm, got a badge reading of 811 millisieverts. She wants the reading to only be 500 millisieverts. To what distance would she have to move? I would tell you, until you get so routine at this that you don't have to do it, do this. It's not going to hurt you. It takes all of probably 1 minute to do this, but if it helps you get it right, then that minute is well worth it. So what's our first thing we come across? 6 inches. So distance happens to be our first distance. Away from the C-arm and the O-arm got a reading of 811 millisieverts. That sounds like our first intensity. Does 811 go with 6 inches? Yes, so that's probably correct. She wants her reading to be 500 millisieverts. So millisieverts is an intensity, a quantity, an amount of radiation. So this is I2. And then to what distance does she need to move? That's our X, and X is our D2. Okay? So what do we do with that? Let me use a marker that'll show up a little bit better. All right, so let's plug in these numbers. Where's our I1? Our I1 is right here, 811. Our I2 is 500. So we've got 1 and 2 equals D2 squared. Well, our D2 is our X. So we have X squared. Don't forget that. Over D1 squared. So we have 6 squared. So there's our setup. 811 over 500 equals X squared over 6 squared. Okay? Now, 6 squared, I told you I would get rid of these first. So 6 times 6 is 36. X squared stays that way. So we cross multiply. So we end up with 500 X squared equals 36 times 811. So we get 29,196. We still want to solve for X, so we're going to divide both sides by 500. Now when we do that, that leaves us with X squared. Don't forget that. Divide 29,196 by 500 gives us 58.392. And then in order to solve for X squared, because you're not done, you have to take the square root of both sides, correct? So I'm going to hit the little square root button on here, so I've got that, and then I hit the square root, and it gives me 7.6414658, but I'm going to cut it so that the square root of X squared is X equals 7.64, because I cut it off, and our distance was originally in inches, so it's going to remain in inches. So if that tech moved to 7.64 inches from 6 inches, she would drop her badge reading from 811 to 500. Okay, so the answer ends up being this. Do I have a qualifier? Yes, inches. If she wants to drop it, then she has to get further away. So is 7.64 more than 6 inches? Yes. So I probably did that correctly. All right. So anytime your variable is on the distant side of the formula, the last step is always going to be to take the square root. If your variable is on the intensity side, you're not going to have to take the square root. Okay? Inverse square law says that as you move further from the source, the intensity or the quantity of radiation decreases, and as you get closer to the source, the intensity or the quantity increases. So inverse, because D2 is over D1, intensity always has to do with some kind of quantity of radiation. So a Rankine, a Coulomb per kilogram, a Gray, a Sievert, a Rem, a Rad, some amount, some quantity of radiation. And your distance, always like inches, feet, centimeters, yards, meters, whatever it happens to be. Typically we're dealing with inches and feet. The other thing that I will warn you about is be mindful that if your distances are different, meaning if it said 6 inches, if one of them said 6 inches and the other one said 1 foot. If it said 6 inches and 1 foot, those are two different things, so you have to make them equal. So you would likely say 6 inches, and then 1 foot is 12 inches. So if you use 6 and 12, then the inches go together. Or you could use 1 foot, and you could use 0.5 because 6 inches is a half of a foot. But the two variables have to be equivalent. So your units have to be equivalent. If you're in inches, use inches. If it's feet, use feet. If it's one of each, go with whatever is easier for you to use, whatever numbers are more manageable. Okay? And that is inverse square law. That's one of the formulas we'll look at. If you can understand this and you can figure out how to cross multiply, it does not get any harder than that, I promise you. This is the most amount of math that you guys are required to do at this point. And it's just to reiterate and understand the concepts of how the intensity changes with a change in distance. While we're on that subject, I'll just throw this out there to see if you could understand this. Let me erase this and try and give you a visual for this. So if we're saying that the farther away you get from the source, that the intensity or the quantity of radiation is reduced, right? And we're saying that that's a good thing, because if we're working in the field and you want to get less exposure, then that's a good thing. So let's say that you have the C arm. Okay, you're in the OR and you're working with the C arm, and with that C arm you're standing here. Okay, and the source is, we'll just say this is the source right here. You're relatively close. But if you were able to back up, okay, if you could move over here, all right, from here to here, let me use something you can see. From here to here versus from here to here. Okay, this is an increased distance, right? So you get a decrease in exposure. Hopefully that makes sense. Whereas this is a decrease in distance, if you compare the two anyway, which means you're getting an increase in exposure. All right, this illustrates the inverse square law. The further you get from a source, you get less exposure. The closer you are to the source, you get more exposure. But does it make sense if I say to you that if you were the patient and we were trying to take an x-ray, then the closer I am to you, which is a specific source to image receptor distance, if I'm closer to you, then I don't need as much radiation to get through you as if I'm farther away. Like if I back up, I'll give you an example. An abdomen x-ray is done at 40 inches. Okay, so I use a specific technique at 40 inches, and let's say it works. I get a diagnostic image. If for some reason I wanted, or the radiologist wanted us to take that same image at 72 inches, I couldn't use the same technique, because what worked at 40, what went through you and gave me an image, at 72 inches, there's not going to be enough to go through you, right? Because when the beam comes out, what does it do? It spreads out the bigger the distance. So when I'm closer to you, it spreads out, right, a certain amount. But when I'm farther away and I'm coming at you, it's going to spread out even more, so that by the time it gets to you, there's not as much. Does that make sense? So the closer it is, the spread is not as great. That spread is called divergence. So when you have an x-ray beam, the primary beam, when it comes out, as it comes out, it spreads out. So wherever your table is, if it's right there and it spreads out a certain amount, if that table was still there but I raised the tube up, now it's going to spread out a lot more because it has more room to spread. Like, think about headlights on a car. When you're driving down the road and it's pitch black, no street lights, no other cars coming, and you just have on your regular headlights, you can see a little bit in front of you, you can see a little bit to the side, but what do we typically do? We put on our high beams, right? What does it do? It gives more light, more intensity, and it spreads it out. So you can see along the sides of the road and further up the road. So the X-ray beam spreads out with an increase in distance, and that spread is called, it diverges, a divergence. Right? And that means that it spreads out with distance. So if you would get less exposure with a greater distance, but if you're trying to image something, you would need to increase the amount of exposure that you used to image the patient to compensate for that divergence. That's another subject, but I just kind of want to give you a heads up of where we're going. And if it made sense, great. If it doesn't, hopefully by the time we get there, it will make sense. All right. If you guys have any questions, be sure to ask. Hopefully that math part made sense. The X and gamma ray originating sources made sense. And hopefully the talking about the photons and the wavelength and the frequency made sense. All right. Study, study, study. See you soon.